Elon, you need no introduction, but for those who don't know, you are the founder and chief engineer of SpaceX and a longtime friend of the Mars Society, and we're delighted to have you back. We've got 9,000 people registered to hear you today.
All right, cool. Sounds good.
Okay.
So I should like change this perspective. Let's see if I can change the perspective. Is that better? Or is that worse?
I think you were better before.
Okay.
Okay. So listen, why don't we just start out with the basics? You started SpaceX to make humanity multi-planetary.
Yeah.
Why do you see that as a critical goal?
Yes. I think we want to be on track to become a multi-planet species and a space-faring civilization in order to find out what the universe is all about, like what, and ensure the continuance of consciousness as we know it. As far as we know, we're the only life. I mean, people think there's aliens, but honestly, I haven't seen any sign of aliens. So as far as we know, we're the only life. Whether we could be the only life, so let's put it that way. And we need to take the set of actions that are most likely to make the future good and result in the continuance of consciousness as we know it.
Okay. So, well, obviously your means to that end is to open the space frontier with reusable launch vehicles, and you've gone through some partially reusable ones, and now it's Starship. Can you explain basically the line of thinking that led you to the Starship design?
I forget what I need to look at to look like I'm looking at the camera. So let's see. Well, on the Starship front, we've gone through many iterations, starting from not really knowing how to build rockets at all with Falcon 1, and having 4 failures actually in reaching orbit. 3 failures, and then the 4th one got to orbit. So 4th one's the charm. So we only barely survived. I was at 0 cash basically when we got that 4th one to orbit, and if that 4th one hadn't worked, we would have been curtains. So it's definitely not been smooth sailing. It's been a very difficult ride, with just a lot that has been discovered along the way. I mean, just trying to figure out what questions to ask about the design was quite difficult. I think it's helpful to have as the objective the creation of a self-sustaining city on Mars. I think this has to be the objective, not simply a few people or a base, but a self-sustaining city. The acid test really is if the ships from Earth stop coming for any reason, does Mars die out? For any reason. It could be from banal, or it could be nuclear Armageddon. Doesn't matter. If the ships stop coming for any reason, does the city on Mars die out? If it does, we're not in a secure place. So, I mean, I think this really might come down to, on the great filter front, are we going to create a self-sustaining city on Mars before or after World War III? And I think the probability of it being created after World War III, hopefully there's never a World War III, but of after is low. So we should try to make the city self-sustaining before any possible World War III. This is just a risk. This is not, I think sometimes people have difficulty dealing with probabilities. It's either this way or that way, but it's really, we just face a series of probabilities. And there's some chance that we will have a giant war or a super volcano, or a comet might hit the Earth, or we might just self-extinguish in some. It might be more of a whimper than a bang. And frankly, right now, civilization is not looking super strong. It's just looking a little rickety right now, to be frank.
Would you say that it's more than a lifeboat, that it would actually make human civilization more robust, clearly more able to divert asteroids from hitting the Earth and otherwise help?
Yeah, it's not an escape vehicle. It's simply something that it's not like you can. I mean, unless Mars is made self-sustaining, which will probably not happen in my lifetime. It is certainly not. It's meaningless to have an escape, lifeboat or escape hatch or something, if you're simply moving to another place where you will soon die out. That doesn't count. It's not much of a lifeboat, really. So this is really about, say, minimizing existential risk for civilization as a whole, and then having an exciting future that you can look forward to, and a future where we are a spacefaring civilization and multi-planet species is far more exciting than one where we are not. I mean, that's an exciting future, and being forever confined to Earth until some eventual extinction event is depressing and not fun. We need things that make you want to get out of bed in the morning and be excited about the future. And I think being a spacefaring civilization is one of those things that everyone can get excited about.
But can you maybe just kind of lead people along the path that led you from the design of, from Falcon 9 to Falcon Heavy, but now Starship is rather different than Falcon Heavy.
Yes,
the engineering.
Absolutely. Absolutely. I didn't quite answer your original question. You first have to say what is the goal, and once you have what is the goal, you can then measure the various designs against that goal. If otherwise, you're saying, how are you evaluating why is one design better than another? What's your goal? It's got to be a goal. So the goal is get enough tonnage to Mars and enough people to make Mars self-sustaining as quickly as possible. So then you say, okay, let's back out the math on this. We're gonna need a lot of tonnage. Maybe, I don't know, 100,000 tons, maybe 1 million tons. So you can't be faffing around with these expendable rockets. They're a joke. They're absurd. Even Saturn V is tiny potatoes. We need it, because if you want to get, like, let's say first order approximation, 1 million tons to the surface of Mars, inclusive of people, that means probably something around 4 or 5 million useful tons of payload into a low Earth orbit. For every ton you get to low Earth orbit, you're going to get 4 or 5 tons, hopefully closer to 5. This math is you really start squeezing like tiny percentages. But let's say confidently, if you got 5 tons to low Earth orbit, you can get 1 ton to Mars. That's confident. Maybe you can get, maybe you only need 4. Anyway, the point is you need 5 million tons into Earth orbit to get 1 million tons to Mars. Now, let's put this into perspective. Total global capacity to orbit of all expendable rockets is around 500 or 600 tons, I think. And if you said, okay, the world's going to end if you do not increase your capacity, perhaps they could do 1,000 tons. Okay, so that's 1/5,000th of what's needed. This is ridiculous. It's not even, 0.1% would be, 1,000th. So way less than 0.1%. We have way less than 0.1% of the capability needed to create if everyone went full tilt with expendable rockets. Expendable rockets are just utterly stupid, in my opinion, utterly stupid. They're a complete waste of time. People should stop wasting their time. If you try to sell an expendable plane, people would laugh you out of the room. If you try to sell an expendable car, they would laugh you out of the room. If you try to sell an expendable horse, they would laugh you out of the room and think there's something wrong with you mentally. So all these things are reusable. It's essential to be reusable. Now, creating a reusable rocket, orbital rocket, is very difficult. Doing a suborbital reusable rocket is easy. Doing a reusable orbital rocket is hard. Even when a lot of smart people have put quite a bit of effort into it, they might get 2 or 3% of the lift-off mass to low Earth orbit. And a really epic rocket would get 4. I'm not sure I don't think anyone's ever gotten 4. But you basically need to have something that in expendable form would probably get about 4% of its payload to orbit, such that you can spend about half of that 4% on reusability and still net out to around 2% of payload to orbit. So you have to make both the booster and the upper stage and the fairing and everything reusable. With Falcon 9, so with Falcon 1, we did actually attempt to do this. So we had a parachute on the first stage, but really did not appreciate that that first stage was going to hit the atmosphere like a concrete wall. So at first I got pretty mad at the parachute supplier until I realized, it's not their fault. We were just big fools. That thing was exploding as soon as it hit the atmosphere. So you really got to do something to ease the transition into the atmosphere at high Mach number. It's very hot and there's a lot of force and a lot of heat. So then with Falcon 9, we made a bigger rocket, and now scale matters here because you do get basically economies of scale. You can't have a tiny rocket. There's a tiny rocket, you basically just end up carrying your electronics to orbit. So your avionics, So in a little rocket, if you're small enough, just your avionics alone ends up being a significant percentage of your payload, and then you end up, if you had a rocket that was, I don't know, trying to get a 10,000 pound rocket, for example, or even a 10,000 kilogram rocket to orbit, I think you would basically get zero payload. Now, as you get bigger, the rocket gets bigger, but the brain doesn't get bigger. The brain can stay the same size. So your avionics, for example, become almost 0% of the weight for a big rocket. Then for big rockets, you also get gauge advantages. So we're really in the nuances of rocket design and manufacturing here. If things are very small, it's difficult to get your gauge accurate. So basically, how thick is the material? Like if you want to do castings, for example, there's a minimum gauge or thickness for a casting. There's a minimum kind of error bar on the on the material skins. Even for a composite rocket, you've got you start hitting granularity issues. As you get bigger, you're no longer gauge limited, and you can get your percentage accuracy on the thickness of walls and castings can be very good. These are nuances that I think almost no one appreciates, but suffice to say that there are advantages to size. And you can certainly see this in many walks of life where if you've got a truck that's carrying cargo, it's more efficient to have a big semi-truck, not a bunch of little trucks. For ships, it would be pretty silly to see container ships or containers going across the ocean one at a time with little outboard motors. That would be silly. You put them on a container ship. You have big ships, not little tiny ships. So anyway, so size matters, it really does. And full reusability matters. So with Falcon 9, after immense effort, we were able to achieve reusability of the booster. And we're mostly achieving reusability at this point with the fairing as well. But this is a monumental effort. And I think within its architecture, Falcon 9 is close to a local maximum. If you say, gas generator cycle, kerosene, oxygen vehicle of this particular size with a 12-foot or 3.6 meter diameter, which is that size because of road transport limitations. So if you go bigger than that, you can't transport it over the road, and your logistics costs become extreme. But having a long, thin rocket is not very mass efficient. You end up having to have thicker skins to take out the bending moment. And then having, like, kerosene is not the right fuel. Methane is a much better fuel. You can get higher ISP. A specific impulse, basically efficiency. I mean, for those who, I think probably a lot of those who are listening know what the rocket equation is, but in simple terms, it's actually very simple. It's like a rocket is going to go further if it shoots the gas out of the end faster, and if a bigger percentage of its mass is propellant. It's obvious. So that's what the rocket equation says. So if you shoot gas out faster in the right direction and increase the propellant, the percentage of propellant, that's going to allow you to go further. With methane, you can shoot it out faster. and
you can make it on Mars.
You can make it on Mars for sure. Exactly. So being able to do in situ propellant development production is very important. So you don't have to carry your return fuel with you, or return fuel and oxygen. It's to be like rockets are mostly oxygen or oxidizer. So and there's some other subtle advantages with a oxygen methane system in that you can go to a higher percentage, a higher mass ratio of oxygen. So with kerosene, you'd be at about roughly 2.5 to 1 oxygen to fuel mass ratio. With methane, you're more like 3.5 to 1. And you actually want that higher mass ratio because oxygen is very dense and it's inexpensive, especially on Earth. So you're gonna, you have all these plants just making oxygen all day long, and plankton just making oxygen, never do anything. So the cost of oxygen is basically the cost of electricity. Anyway, so going from Falcon, going from kerosene, which is basically the same as jet fuel. It's like RP1, rocket propellant grade kerosene, is just a tighter grade of jet fuel. You want to go from that to something which has where the gas shoots out faster, and that's methane, and where in situ production of propellant is easier. So that's why the change from kerosene to methane. Methane is just CH4. It's 1 carbon, 4 hydrogens, and then the oxygen pairs together. So you have it's called O2 because oxygen pair bonds. And obviously you know all this stuff. I'm just basically
so that kind of
for the audience
together. Large size, twice the takeoff thrust of a Saturn V, but about the same payload, but that gives you reusability, much cheaper, in situ propellant. It all is coherent. And so let me ask you the thing that I think everybody wants to know, which is when? When are we going to see Starship do a high fly to stratosphere? When to orbit? When first payload to Mars? When first humans to Mars?
All right. Well, it's not like we're obviously venturing into unknown territory, so it's not as though I have all these secret dates and I'm just keeping them from people. But so these are just guesses, obviously. I'd say I'm 80 to 90% confident that we will reach orbit with Starship next year. I think probably 50% confident that we'll be able to bring the ship and booster back. That's more of a dicey situation. We'll probably lose a few ships before we really get the atmospheric return and landing right. We might lose. Hopefully we don't lose it. Hopefully we don't lose any boosters because that's a lot of engines. Our initial booster flights will just have maybe 2 to 4 engines, not 28. 28 is a lot of engines. So and then I think we'll probably be in doing high volume flights. I think probably in 2022, so a couple years from now. But I'm trying to make sure that our rate of innovation increases, it does not decrease. This is really essential. In fact, if we do not see something close to an exponential improvement in our rate of innovation, we will not reach Mars. Like a pure linear doesn't get there. Well, I'll be dead anyway before it gets there if it's pure linear. If it's exponential, I think we could get to Mars. We could probably send an uncrewed mission there in maybe 4 years. there's a Mars conjunction every 26 months. There's one this year, so that means in a couple of years from now there's another one, and then 4 years from now there's another one. I think we've got a fighting chance of making that second Mars transfer window.
So
Yeah.
one thing that is really amazing about SpaceX, to those of us who have experience in the aerospace industry, is the rate of innovation. Okay, last time you spoke to the Mars Society convention was 2012. Since then, you've made the Falcon 9 reusable, introduced Falcon Heavy, the Crew Dragon, a satellite constellation, and you're in the middle of developing Starship. So what is your, what would you say is your methodology that allows you to innovate so swiftly?
I don't really know. We're focused on, like I said, it is important to have the objective be right. That's why I was talking so much about the importance of making Mars a self-sustaining, building a self-sustaining city on Mars. If that's the objective, then obviously, just putting some satellites in orbit that's not important. You have to achieve full and rapid reusability. I emphasize full and rapid. Reusability is only relevant to the degree it's rapid and complete. And then you also have to do orbital refilling. This is essential as well. And then propellant production on Mars, also essential. So, with that as the goal, then that means that creates, I think, a good forcing function for radical innovation, because in the absence of radical innovation, we have no chance of meeting that goal. Whereas if our goal was simply, defeat Lockheed and Boeing or something like that, we would probably achieve.
You've already done it.
That really wasn't even a thing, Yeah. I wish it was. They're not even trying to do reusability, which is bizarre because they make planes that are reusable. So, I mean, if they talk to if they talk to one of their customers, buys a Lockheed fighter jet or a Boeing aircraft, like, hey, we're going to sell you a 737. It can be used once, and it's not a 737 Max. But that turns out that was a single-use airplane at times. But it really. It would be an absurd thing for them to sell a single-use aircraft, but they feel quite comfortable selling a single-use rocket. And anyway, but if our goal was simply we're going to be the leaders in launching the conventional satellites that exist, we would probably approach that on a sort of a logarithmic basis, where you'd get there and you'd sort of slowly make progress towards doing 10 launches a year, 12 launches a year, and while they do 6 or something like that. I don't know. But since the goal is, hey, we need to make life multiplanetary before it's too late, and time really matters. So it's like we're shooting for Mars, not just the moon. It's not let's shoot for the moon, shoot for Mars. And then these competitive things are kind of small things along the way. Unless somebody else is shooting for Mars, they will not be competitive with something as pedestrian as launching a few satellites into Earth orbit.
So how can the Mars Society help you?
Well, I do think there's, in order for there to be a self-sustaining city on Mars, we're going to need an intersection of sets here. One set is the set of people that want to go and can either find sponsorship, they can either afford it themselves or find government sponsorship or take out a loan or whatever the case may be. But somehow you've got to have the set of people who want to go to Mars and can come up with the funds somehow to do that. And then I should say there's two sets: desire to go to Mars and can afford to go to Mars. When desire to go to the people who want to go to Mars, and the people who could afford to go to Mars, when that intersection of sets reaches 1 million, roughly, then I think we will have this city on Mars. So we need both the motivation and we need both the means and the way. I mean, it's like we need people to want to go.
The will and the way.
The will and the way. Yes, exactly. The will and the way. Where there's a will, there's a way. But in this case, we need will and a way. So when the will and the way intersect, then we will have a multi-planet species. The will and the way must intersect. So I think the Mars Society can really help with the will.
Okay, you provide the way, we'll provide the will.
Yes, exactly.
Okay. Now, your assistant Jen told me earlier that you have a hard cutoff at the half hour. Is that true, or do you want to stay and take some questions from the audience?
Yeah, we could do maybe 5-10 minutes of questions.
All right, great. So we've got hundreds of questions. So Jim, do you want to read a question or two?
Yeah, sure thing. Hi, Elon. My name is James Burke. I'm from Seattle, Washington. Where's the best place to land on Mars, do you think?
Yeah, actually, I'm not super sure. I can tell you what the criteria are that you'd want. You'd want to be, anyway, I think the short answer is mid-latitudes, probably on the north. So you want to be close to ice. You don't want to be too you don't want to be too far away from the sun so you can get solar power, and you want to land at a low altitude so that you can take maximum effect of atmospheric braking. What do you think?
I like Melas Chasma. It's a nice little area at the bottom of Valles Marineris. The air pressure's high.
Okay. Is there a lot of ice there?
There's ice around there. We'd have to look for it, though.
Okay.
That kind of brings me to my next question, and then I'm going to turn it over to Carrie to ask you one. How would you prioritize like missions like 2 through 10? Are you going to focus on exploration or building up the infrastructure or science?
We're going to, I think the first order of business is build a propellant plant. I mean, we can for sure lob out a bunch of droids, that's no problem. I think why not? We're going, and probably if anyone wants to put their droid on, we could just take it. And, it's like, hey, it's basically a remote control car, a solar powered remote control car. And we could provide the communication relay. So, you could just basically connect to your car from your computer at home and, cruise your electric. You could have legs too, it doesn't matter. Your robo device / car. That would be pretty cool. There's a lot of people worried about life contamination. It's like, listen, anything that can survive on Mars is so freaking tough. It's insane. That it is cold and there's like a lot of UV radiation, and it's not going to be too worried about anything we send from Earth. Let me put it that way. It's just tougher than anything on Earth. But I think the first order of business is we've got to build a plant to make propellant, and so we've got to need a lot of energy. We've got to mine some ice, and you got CO2 from the atmosphere. So from the ice, you got the H2O. Combine the H2O with the CO2, you get CH4 and O2. But that's a lot of energy, and it'd be quite hard, I think, to make that propellant plant reliable. But that's the primary order of business, and then we could also look around and see if we can learn anything from a scientific standpoint.
Carrie, do you want to go next?
Sure, thank you, James. I'm Carrie Fade. I live in Denver, Colorado. Thank you for joining us today, Mr. Musk. We do have a lot of questions from 13, 14-year-olds. So I'm just going to pick one and ask you. It's from a teenager, and her name is Dara. And she wants to be an engineer and build starships and robots. And her dream is working for SpaceX. What should she focus on to be an engineer?
Well, I think there's all kinds of engineering that's needed. So you don't have to be an aerospace engineer. You could be in electronics, mechanical engineer, electrical engineer. You could be a software engineer. I mean, there's a lot of engineering, basically almost any kind of engineering. We'll need chemical engineering, I think, also for figuring out how to make a good propellant depot, or I should say propellant production plant. Yeah, I think physics in general is a good background for thinking. I just generally recommend people take physics courses because physics has the best tools for critical thinking.
Thank you, Elon. James?
Yeah, thanks, Carrie. Another question. The Boring Company. Now, is that just kind of an outfit to build tunneling machines that can work on Mars?
No. The Boring Company actually started as kind of a joke. And for a lot of times people would ask me, what do I think the opportunities are out there? And for, I don't know, 5 years or more, I kept saying, can someone please start a tunneling company? Because I think tunnels have a lot of opportunity for alleviating traffic in cities and just improving quality of life overall. I mean, there's a lot of streets you could turn into parks. Certainly you wouldn't need parking. You could just park cars underground. So, and everyone thought I was joking. And I was like, well, I guess we'll see what it takes to drill a tunnel, dig a tunnel, and all these like so-called traffic experts and like haven't really made much progress. Cities like LA and DC are still a traffic nightmare. I'm like, okay, guys, well, if you got such great ideas, why is this still a traffic nightmare? So if you build tunnels, you got to go 3D somehow, either underground or above ground, like either air or ground. And the problem with air is like, anything that can carry a person is going to generate a lot of noise and a lot of wind force. So, and could fall on your head, and also kind of not be good for privacy. And like, you're sitting in your backyard and someone like flying over you is like not that cool. So, but tunnels are working all those things. They're also weatherproof. Don't have any privacy issues and safe. And anyway, they would make a big difference to traffic. And we have the first production tunnel or useful tunnel in Vegas that's going to open, I think, in a month or two. So a few months, I guess. And hopefully we'll be ready for prime time around the Consumer Electronics Show. Now for Mars, I think tunnels and digging in general is good, but you need to build a very light system compared to what would matters on Earth. You don't really care all that much about mass on Earth. You care a lot about mass going to Mars.
Is it fair to say that you're learning some techniques that might apply to Mars with the Boring Company?
Yeah, probably.
When do you think Starship will be able to be demonstrating refueling in low Earth orbit?
I think we got a shot at doing that in 22, about 2 years.
And then when do you guys think you'll have a moonship prototype?
Probably 2 or 3 years. As soon as you've got orbital refilling, you can send significant payload to the moon. Like significant meaning 100 tons of useful payload at a shot.
So then from there, I think you mentioned Mars is a couple years after that.
It's only a couple years after that because the Mars transit window is every 26 months. Like I think we maybe have a shot of sending, or trying to send something to Mars in 3 years, but the window is 4 years away because of the being in different parts of the solar system.
Carrie asked a question from a young person. I'd like to also ask, do you have any tips for young people who love Mars but don't know how to help with the settlement of Mars?
Well, I think definitely, anyone who is a strong advocate for Mars, I think this really makes a difference. A lot of times it's not even, people aren't even thinking about it. And, you can talk to people at a party or talk to friends, and like, it's just not even a topic of conversation. So I think it could really help if everyone out there who thinks this is important for the future of humanity and consciousness as a whole, to make it part of what people are thinking about. Bring it up at at parties and talking to friends and online. It's like, it should be a thing that we do. And I think it's worth, maybe 1% of our resources at least. And that's not going to fundamentally change things, quality of life. If we spend 1% of our resources, much less than healthcare, obviously, maybe probably even less than we spend on cosmetics, frankly, then that would be enough to make life multiplanetary. But we really need to make this a thing people talk about at least 1% of the time, and that would really matter. As we were talking about earlier, we need the will, which is we need a critical mass of people wanting to make it happen, and then we need the way. And SpaceX is going to try hard to provide the way, and then once we show that there's a way, probably there'll be other companies that also try to do it as well. So we need the will and the way. They can provide either. The will is extremely important. It makes a huge difference.
What's the coolest part of Starship development?
Well, I guess the coolest part of Starship development is working with just a great team of engineers and coming up with interesting solutions. I think it's just fundamentally enjoyable if you're working with a lot of good, smart people creatively towards solutions that have never existed before. That's very rewarding. So I guess probably I like that the most.
Can you talk a little bit about how Starship could be used for other destinations in the solar system, like Venus and the outer planets?
Starship is definitely a generalized ship. It basically it solves for transport anywhere in the solar system where there is a solid surface to land. So if you can land there, we're going to take there. We'll also actually go into the atmosphere of Venus, for example, just like go into orbit and perhaps to the upper atmosphere. Venus's atmosphere is extremely dense, it's also quite hot. But because of that dense atmosphere, you could have something. You could have a kind of like some sort of dirigible, some kind of like things that could float on Venus that could not float on Earth in the atmosphere because of the dense atmosphere. So you could go to Venus. I mean, it's not a super friendly place. And then like Mercury is super hot. I think that we could go to Ceres or any of the asteroids, the moons of Jupiter, although there'd be quite high radiation around there. And then out to Saturn, eventually getting out to, the sort of Kuiper belt or cloud and that kind of thing, the outer solar system. So Starship, once you have propellant depots, you can kind of like planet hop or moon hop around the solar system. It's not a vehicle that would enable us to go interstellar, but it's that's a tough one. But we need to make the leap of going to another planet first. Once we are a multi-planet species, we will create a forcing function for the rapid improvement of space flight, and we'll figure out new technologies that will ultimately allow us to go to other star systems.
What do you look for in the people you hire, especially the engineers?
Really just look for evidence of exceptional ability. So it's not, or at least aspirationally, like sometimes these things get messed up in recruiting, or the recruiting filter ends up being wrong. Like I sometimes wonder with Tesla, if Nikola Tesla applied to Tesla, would we even give him an interview? It's not clear. This guy came from like some weird college somewhere in Eastern Europe. He's got some odd mannerisms. Now we don't know if we should give him an interview. Like I worry that that's actually what we do instead of like, it should be like, man, Nikola Tesla, this kid's super smart. What does he want? We'll pay him anything. That should be that should be the reaction if Nikola Tesla applies, to Tesla, ironically. But I can tell you the intent is we're looking for evidence of exceptional ability, and it really doesn't matter if you went to graduate high school or college or anything. We're just looking for evidence of exceptional ability, such that it would be a good predictor for doing exceptional things at SpaceX.
right. Do you have some more questions from the audience
Yeah.
there, Jim?
I've got one. So have you thought about communication networks between Earth and Mars and kind of, I mean, you're working on Starlink. What about like an internet around Mars? Have you thought about that?
Yeah, I mean, you could certainly do some variants of Starlink. This will probably have to be the last question because I've got a bunch of things piled up. But yeah, you could just do a version of Starlink around Mars, and then you just need a big laser coming from Earth. Probably want it to be in orbit so it doesn't get atmospheric diffraction or attenuation. You want to go from a big laser from Earth orbit to Mars orbit, and then you're going to need some relay stations for when Mars is on the other side of the sun. So you can't just shoot a laser through the sun. All right, thank you.
Thank you so much, Elon. We're all pulling for you. Good luck.
Yeah,
All right,
and
much
good luck.
appreciated. And just like a thank you to all the people out there that are fighting hard for the cause of Mars. There's not that many, and we need more. Thank you.
All right, thank you. Okay, and so listen, Elon has to go, but I'm willing to take questions for the next 15 minutes until the next session starts. So ask me anything. Got some questions there, Jim?
I've got a lot of questions, Robert. Let's see. What's the current, let's see, a lot of these are for Elon, so I'm gonna have to adapt one for you. Do you see electric rockets happening in the next 100 years?
Well, electric propulsion is already in use. The problem with electric propulsion, it's a low thrust system intrinsically. So if time is not an issue, but delta V is, that is the total amount of velocity changes you need to do, then electric propulsion is a good system for that. So for instance, the Dawn spacecraft visited several different asteroids when puttering around the asteroid belt. That was done with electric propulsion. That was great. But electric propulsion is, for instance, not the way we're going to get quick trips to Mars. We'll get quick trips to Mars. We cheapen the cost of the space launch. We can put more propellant on a rocket. You know, if that's what we want to do. Actually, if we can get more stuff to orbit, I'd prefer to deliver more payload. But electric propulsion is a useful ancillary technology. But until we have very high energy, high power to mass ratio space power systems, very high power to weight space nuclear power systems or fusion power systems, electric propulsion will remain an auxiliary technology. If we do get that kind of stuff, well, then the situation will change. And especially for the outer solar system, where you've got more time to pick up speed. But if it takes you 6 months to pick up speed, you can get to Mars in 6 months with chemical propulsion. But right now it takes several years to reach Jupiter. So an electric propulsion system might be useful for that.
Here's a classic for you. Do you like the current plan of going to the moon, from the moon to Mars, or do you think we should go straight to Mars?
Well, if you want to go to Mars, you need to go to Mars, okay? There's reasons to go to the moon for going to the moon, but the moon is not the way to go to Mars. Going to the moon is the way to go to the moon.
Do you have any advice? I kind of asked him about advice for young people that are interested in Mars but don't know how to help directly. Do you have any advice for those folks?
Well, you know, first of all, if you want to participate directly, learn all the science and math you can. That way you can become a scientist or an engineer. Although there's going to be other fields necessary for colonizing Mars, agronomy, we're going to want to have automated, highly productive greenhouses, genetic engineering of new crops. All the sciences come into play. This is a vast human endeavor. And if you're not inclined towards the sciences, you know, if you've got a way of spreading the vision, as Elon said, we need both the will and the way, and people who can recruit other people to the cause are as valuable as people who can participate directly.
Here's a really good one. Do you think the first civilization on Mars will be more of small living spaces, like small bubbles and such, or more normalized, like tall buildings?
Well, I don't think tall buildings are an appropriate architecture for Mars. I think that what we'll have is we can have extensive living space underground, like whole metro systems, and then domes on the surface. So I think, people can spend, about 20% of their time in the domes, in the sunlight above the surface, and 80%, sleeping downstairs and doing other things downstairs where you're completely shielded from space radiation. That's my personal view of the most probable Mars architecture.
Do you think Mars colonization can be done solely by SpaceX, or will it be done collaboratively?
No, this is a much bigger endeavor. SpaceX is taking on the biggest single challenge, which is the transportation system. There's all sorts of other systems that are going to be needed. We're going to need propellant making systems. We're going to need automated food factories. We're going to, because there's going to be a tremendous labor shortage on Mars. Mars needs people, and it's going to be shorthanded for a long time. So all kinds of labor saving machinery, robotics, artificial intelligence, energy technology, whether it's nuclear or solar or even perhaps geothermal for Mars, or fusion power would be terrific for Mars, because Mars has got 6 times the deuterium that Earth has as a percentage of its hydrogen. There's a lot of things that one could think of. There's all sorts of engineering problems that need to be addressed. And, my personal hope is that, we're going to see Starship reach the stratosphere before this year's out. And if Elon's right, reach orbit next year or the year after. And this will change people's minds as to what is possible. And then, we'll have NASA seeking to fund the remaining pieces of the puzzle, or entrepreneurs stepping forward to develop remaining pieces of the puzzle, space nuclear power reactors. We had a great talk today from David Poston, but it would sure help if some private money got into that game to move the most advanced concepts along faster than the pace that DOE is willing to support. And frankly, we could use people playing the political game who are on our side. So there's a lot of ways that people can help, and there's a lot of other technologies that need to be developed. But by making the transportation system, by showing that we can deliver large payloads to Mars, then all of a sudden, all sorts of other technologies can get a chance to play.
Carrie, did you want to ask a question, Robert?
I do. Hi, Robert. This is from one of the questions from our Q&A. Have your thoughts outlined in the case for space changed with the progress and current direction of SpaceX since the most recent publication of that book? If so, how have they changed?
Well, they haven't changed that much. In the case for space, I talk about how the entrepreneurial space launch revolution is changing the game relative to what it was when I wrote the case for Mars. Now, Musk is moving pretty fast, and it's become more clear to me how he intends to accomplish orbital refilling, because that's a hard thing to do. No one's ever done orbital refilling of a cryogenic propellant. But I think he's got a good plan, which is to take 2 Starships base to base, accelerate them just slightly in the direction of the tanker, that is in the direction of the one that is supplying the propellant. So it is in the up position, as it were, from the gravity, and then point of view, and then just drain its tanks down into the other one. And by the way, another advantage of methane oxygen that I'm sure Musk is quite aware of, but he didn't have a chance to mention, is that the 2 propellants store at the same temperature. So the tanks can be in intimate contact. There's no issue of thermal contact between the methane tank and the oxygen tanks, which there is, say, with kerosene and oxygen. Okay. Kerosene would freeze at liquid oxygen temperatures.
Thank you, Robert. James?
What do you think is the biggest or hardest challenge that SpaceX has to pull off what they're trying to do with Starship?
Well, they have a challenging system there. I mean, first of all, the booster, it's got about, last time I saw 31 engines. I heard one design where they might reduce it to maybe 28 or so, but still order of 30 engines on the base stage, and all firing. Of course, with that many engines, you can afford engines going out. They have a massive, reliable engine out capability, but if an engine should explode, that would be very bad. There's a lot more things that could go wrong. There's more resiliency against things going wrong. So this thing's got twice the thrust of the Saturn V, and it's reusable. Now, that's the other thing. The upper stage, the Starship proper, it's going to go to orbit. Now, we saw, shuttle coming back from orbit. It had these tiles, and it would take quite a while to refit them after each landing. And of course, in the case of Columbia, the tiles came off and it failed on reentry. Now, there are more, shuttle tiles is 1970s technology, and it's unfortunate that NASA never went beyond that, never refitted shuttles with more advanced thermal protection that became available over the following decades, and certainly Musk is starting from the point of view of the most advanced technologies available today. But he is basically attempting to repeat or solve in a new way all the development that went into the Saturn V and all the development that went into the space shuttle, and additional development being orbital refilling. Now, this guy, he's got the best rocket team since von Braun. That's why I asked him several questions about who does he hire, or how does he approach this, because, as impressive as the actual space flight hardware of SpaceX is the organization itself. It's just from the point of view, I run a company, I have 20 employees, so it doesn't compare to SpaceX, but still it is hard to hire the right people, and to hire so many people and choose the right ones on such a scale and organize them to be effective. And this is incredible management skill here.
That kind of reminds me of the story you told at one of our banquets a couple years ago when Elon was just thinking about starting SpaceX, and wasn't he actually involved with the Mars Society before that?
Well, yeah, Elon was actually a member of the board of the Mars Society for a while. But, he decided that he could accomplish much more by creating a launch company to open the space frontier. That he set himself the hardest task that needs to be done to make all this possible. And what we need to do is go and recruit more Elon Musks to solve the problem of space nuclear power, to solve the problem, of good life support, of solve the problem of automated agriculture. There's a whole bunch of technical problems here that need to be solved. And there's money to be made doing it, by the way. There's a lot of money waiting to be doing it. And these are hard problems. There are people working on small modular nuclear reactors right now. They are small relative to commercial reactors on Earth, but they're large relative to any power system that has ever been done in space. These are entrepreneurial efforts. And, this is a hard thing to do, to make money in that business. Frankly, if all Musk had done was make money in the electric car business, he would have, defied the odds, because no one ever did that before either. But there's a lot of other businesses here that need to be taken on, okay? And I see our job in the Mars Society is inspire people to want to take them on, and hopefully some of them will succeed and all the pieces will come into play.
What do you think of the operation that he's got going on down in Boca Chica? I've heard you describe it as a Starship production line, essentially, that he's building, not just one vessel.
Yeah, I went and I visited him down in Boca Chica in February, and I saw this thing growing there. It was a sight to see. He at that point had about 250 people there. My guess, we didn't ask him today, but my guess is he probably has tripled that by now, and he'll triple it again in the next 6 months. He's not just developing a ship, he's developing a shipyard. The Starship, in addition to its performance characteristics in terms of how much payload it can do and so forth, is designed to be mass produced. Okay, this is a mass production, fully reusable heavy lift booster. He wants numbers. And he's learned that, the first launches of vehicles, it could very well fail. He is turning out these prototypes right now at a rate on the order of one a month. So he's prepared to take losses. And you heard him today say, we expect the first several to fail. Okay, NASA could never afford a space shuttle to fail. Of course, two did over the course of the program, and that was those were total disasters, mega disasters. And both from the human life point of view, but also from the financial point of view and the program capability point of view. He's not going to launch a Humans to Mars program with 4 starships. He'll probably have 100 by then, and more after.
Looks like we're at 4 o'clock. Carrie, do you have one more question? Or are you good?
I'm good, thank you.
Okay. I think we're gonna need to leave it there, Robert. We've got a bunch of track talks starting at our conference.
All right. Well, thanks to everyone. And this year, the one piece of good news was Crew Dragon. In the midst of all this mess we've been living through, that was the one light in the darkness. And I'm hoping for one more Starship reaching the stratosphere by December. Maybe it'll happen. I hope it will.
Thanks, everybody. This is the Mars Society signing off. See you on Mars.
Thank you, Robert. Thank you, James.
See you on Mars.
Wonderful to be here. Feet on the ground, planet Earth, as it were. We're going to be touching on some really interesting topics tonight. We've got an amazing panel, and I'll give a brief overview of